Divide and conquer is such an amazing algorithmic paradigm. It speeds up your process so much. And to be very honest, I was very surprised and very happy when I found out that this problem can be solved using the binary search technique. Yes, that is a very big hint. Hello friends, welcome back to my channel. First, I will explain you the problem statement and we will look at some sample test cases. Going forward, we will start to understand what is the choke point when you are applying the brute force method. And then going forward, we are going to optimize it and solve this problem using the binary search technique. After that, as usual, we will also do a dry run of the code so that you can understand and visualize how all of this is actually working in action. Without further ado, let's get started. First of all, let us try to make sure that we are understanding the problem statement correctly. In this problem, you are given an array where each element represents a pile of bananas. So, if we look at our first test case, I have these 4 elements. That means in the first pile I have 3 bananas and in the last pile I have 11 bananas, right? What you need to do is, Koko has to eat all of these bananas and the time given is only 8 hours. So you have to tell me what should be the minimum speed possible for Koko such that Koko is able to eat all of these bananas before this time expires, right? So I know that this is a lot of information to process. So let me try to visualize this particular test case for you. And then things will become even more simpler. This should make things simpler now. What I have over here is my first test case. And each of these numbers, these are the pile of bananas, correct? So my first pile has 3 bananas, second pile has 6 bananas, third pile has 7, and the last pile has 11 bananas, right? And Koko has to eat all of these bananas before the time expires. She has a total time of 8 hours. Now, according to the question, Koko can set an eating speed. Let us say Koko eats only 1 banana per hour, correct? Now, she has to start eating all of these bananas. What will happen? In the first pile, I have 3 bananas, correct? So, if Koko has to eat, in the first hour, she will eat 1 banana. This will be for the second hour and this will be for the third hour, correct? So, up till now, how much time Koko has taken? Koko has taken a total of 3 hours, correct? And she has only eaten 1 pile. Koko has to eat all the bananas. Now, she will go on to the next pile. Once again, she starts to eat 1, 1, 1. So, 3 plus 3, 6, and then 7, and 8, and a 9. To eat these 6 bananas, she will need 6 additional hours, correct? Because her eating speed is only 1 banana per hour. So, how much total time she has taken? She took a total of 3 plus 6. That is 9. But now, if you notice, the total time available was only 8 hours, correct? Koko has taken 9 hours in total and she is not yet finished. So, it means that this eating speed was slow. Koko needs to increase her speed, correct? Let us say this time Koko is eating at a speed of 2 bananas per hour. Then what will happen? Once again, she starts from the first pile. In the first pile, she eats 2 bananas, correct? So, now she took 1 hour. This pile still has 1 banana remaining. This question has one more condition. And that condition is Koko cannot change a pile during any hour. So, although Koko can eat 2 bananas per hour, she cannot say that, okay, I will eat 1 banana from this pile and 1 banana from this pile. This cannot happen. So, what will happen is, in the next hour, Koko will only eat 1 more banana. So, for the first pile, Koko took a total of 2 hours, correct? Now she can move on to the next pile. In the next pile, in the first hour, she eats 2 bananas. In the second hour, she eats 2 bananas. And in the third hour, she will once again eat 3 bananas. So, she took a total of 3 hours, correct? And the total time has been 5. Now, if you notice, she still has 3 hours remaining, correct? So, what will Koko do is, she will try to go on to the next pile. When she goes on to the next pile, she eats 2 bananas in 1 hour, 2 bananas in 1 hour, 2 in 1, and then once again she has 1 banana remaining. But according to our condition, she will only eat 1 banana. So for the third pile also, she took a total of 4 hours, right? So how much more time? 5 plus 4 and that is a 9. Once again, what happened? She already took 9 hours, one pile is still remaining, and she only had a total of 8 hours. So this way again, her speed to eat was less, correct? Let me tell you about an extreme case now. What happens if Coco begins to eat 11 bananas per hour? Then, if you notice, in the first pile, she will eat all of these bananas in just 1 hour. She cannot change the pile, so she will have to wait. She only took a total of 1 hour, right? Now, she can move on to the next pile. And once again, she can eat all of these 6 bananas. Once again, 1 hour. Moving on to the next piles again, she will eat all the bananas from the third pile and then all the bananas from the last pile in 1 hour each. So, if you notice, how much time did she take? She took a total of only 4 hours, right? Now, this is a valid scenario. Coco was able to eat all of these bananas and she only took a time of 4 hours. But she still had 8 hours available. So, she still has some time left. So, in this problem, what you have to do is you have to keep on increasing this speed only up to a limit by which Coco can eat all of these bananas. Notice that if you have a very high value, then yes, she will eat all the bananas. But according to the question, Coco wants to eat as slow as possible. If she eats very slow, if she is eating only at 1 banana per hour, then she cannot finish it. If she is eating so many bananas, then her eating speed is too high. So what you have to do is you have to find the minimum speed possible such that Coco is able to eat all of these bananas, right? For this particular test case, 4 is your answer because when Coco is eating 4 bananas at a time, she completes the first pile in 1 hour. For the second pile, she will take 2 hours. For the third pile also, she will take 2 hours. And then for the last pile also, she will eat 4 bananas, and then 3 bananas. So for the last pile, she took a total of 3 hours. Now, if you add up all of these values, you get a total of 8. So if you notice, she ate all of the bananas in 8 hours and that was the time available to her, correct? So that is why 4 is the minimum possible speed by which Coco can finish eating all of these bananas, correct? Coming back to the problem now, if you notice, for the first test case, 4 was your answer. Similarly, for the second test case, my array has changed again, right? And the time available is only 5 hours. So Coco will have to eat at a higher speed, right? For this particular test case, 30 will be your answer. And if you notice, in the last test case, my array is same as the second test case. But the time has increased. That means Coco has more time to eat all of the bananas. So naturally, the speed at which Coco should eat should decrease. For the last particular test case, in fact, 23 is your answer. So now you exactly know what does the problem statement actually mean. If you feel that now you have understood it even better, feel free to first try it out. Otherwise, let us dive into the solution and understand how can you derive all of these answers actually. If you now want to approach the problem in a brute force way, what can you do? You can gradually start to increase the speed at which Coco is eating, right? So what did we do? First of all, my speed was 1, correct? So how much time did Coco take? So Coco will take 3 divided by 1 plus 6 divided by 1 plus 7 divided by 1 plus 11 divided by 1, right? Where 3, 6, 7 and 11, they are the piles and 1 is the eating speed. So how much time do you get? You will get a total of 27 hours, correct? So when the speed was 1, the time taken was 27. What you will do now is, you will now try to find out, okay, how about 2 bananas per hour? Then once again, you will do 3 divided by 2 plus 6 divided by 2 plus 7 divided by 2 plus 11 divided by 2. And if you notice, 3 divided by 2 will actually give you 1.5. That means there is some time remaining. So what we'll actually do is, we will take the ceiling value of all of these numbers. Because we cannot move on to the other pile. So what will happen is, this is going to revolve to 2 hours, then 3 hours, then 4 hours, and then 6 hours. So the total time taken will be 15 hours. So basically what we are doing is, we are kind of iterating over each of the speed. For a speed of 1, you will need 27 hours. For a speed of 2, you will need 15 hours. Similarly, you will go ahead and then try the speed of 3. For a speed of 3, you will get your values 1 hour, 2 hour, 3 hours and 4 hours. That is because you take the ceiling value. Try to think. Because if you're eating 3 bananas, in the first hour you eat 3, in the second hour you eat 3. And then you have 1 banana remaining, so you will take an additional hour. Similarly 3, 3 and then 3 again. You have 2 bananas remaining, so that will take up additional hour. That is why you get 1, 2, 3 and 4. So that gives me a total of 10 hours, right? For the next iteration, you will put down your speed as 4 hours, and for the value of 4, the time will turn out to be 8 hours. So what are we doing over here? We will keep on incrementing our value until we find a time that is within this limit. Notice that if you go ahead, if the speed changes to 5 bananas per hour, then this will even reduce. But you don't want Koko to be eating too much. You want her speed to be minimum such that she is able to finish all of it. Correct? So that is the brute force approach, and you will safely say that, okay, when Koko's speed is 4 bananas per hour, she will be able to finish all of the bananas in 8 hours. So this is the brute force approach. How do you go about optimizing it? So once again, I have the same sample test case, and we have to think about optimizing it. If you have understood the problem statement correctly, now you know 2 more pieces of information. That is the minimum speed at which Koko can eat and the maximum speed. The minimum speed at which Koko can eat is 1, correct? Because she has to eat at least 1 banana per hour. And what is the maximum speed? The maximum speed will be the largest element that you can find in this pile. Because think about it. If Koko can eat the largest number of bananas that are available in a pile in an hour, then for every other pile that is smaller, she will be able to eat all of them. So if she can eat 11 bananas in an hour, then for every pile also she will take 1 hour each. And that is the best case. You do not have to go faster than this, right? So it clearly tells me that the maximum speed at which Koko can eat is 11. So what does this tell you now? It tells me that to find the optimum speed, that optimum speed will be somewhere in between over here, right? It cannot be less than 1, it cannot be greater than 11. So what I have over here is, I have all the possible speeds, right? I have a minimum speed that is 1 and I have a maximum speed that is 11. What else do you have? You have a sorted array. You have all of these values, a low pointer and a high pointer. And you have to find the optimal speed somewhere in between. So that is a very good and a clear indicator about the binary search approach. In the brute force approach, what were we doing? We first tried 1 banana per hour, then 2 bananas per hour, then 3 bananas per hour, and then we went on, right? A binary search helps you to eliminate half of your sample test case easily. So what will you do? Low is at 1 and high is at 11. So finding out the mid value, I land at 6. So basically what we're going to do is, we will first try with 6 bananas per hour. When I try eating 6 bananas, for the first pile, how much time I will take? I will just take 1 hour, right? For the second pile, how much time I will take? I have 6 bananas, so I will eat all of them. I will take 1 hour again. What about the third pile? The third pile has 7 bananas, so I eat 6 first and then 1 again. So I take 2 hours. For the last pile, I have 11 bananas, so I eat 6 bananas in one go and 4 bananas in the second hour. So once again, I take a total of 2 hours. So how much time did I take in total? I took a total of 6 hours. The time available to me was 8 hours, correct? And I was able to finish my job in 6 hours itself. That means there is a chance that I can slow down my speed because I have some time available, right? So as per the binary search technique, what you can do is, you can bring your high pointer now to 6. And what does that do? This will eliminate half of your array. This part has now completely gone, right? And once again, to find the next iteration, what will you do? You will look at the low and the high. Find out the mid value now. The mid value will be 3, correct? So this time we are gonna try to eat 3 bananas at a time. When you are eating 3 bananas, for the first pile, you will take a total of 1 hour. For the second pile, you will take a total of 2 hours. For the third pile, you will take a total of 3 hours. And for the fourth pile, you will take a total of 4 hours. So, what is the total time? The total time is 10 hours. And once again, what do you notice? You took 10 hours, whereas you only had 8 hours available. That means you need to increase your speed, correct? So, as per the binary search approach, what will I do? I will move my low pointer to 3 now. And with this, I will eliminate the left side of the array. You see that I have totally eliminated these options and these options. My sample size has reduced so much, correct? Once again, what will you do? You will look at the high pointer and the low pointer, try to find out a mid value, and then once again try to find out the total hours. And you will keep on doing this until both of these pointers meet. As soon as both of these pointers meet, you know that this is the optimum value by which Koko can finish all of the bananas within this given specified time. Now, talking about the time complexity. Since you are applying the binary search approach to find out these elements, you have a time complexity of log of n. And also notice that for any number that you pick, you have to iterate through your entire array to find out the total number of hours. So that changes the time complexity to n also. So the total time complexity of this solution turns out to be order of n log n. And the space complexity of this solution is order of 1. Because I am not taking any extra space to arrive at my solution. Now, let us quickly do a dry run of the code and see how it works in action. On the left side of your screen, you will have the complete code to implement this solution. And on the right, once again, I have a sample array and the time available that are passed in as an input parameter to the function min eating speed. If you notice, what is the first thing that we do? First of all, we assign a minimum speed, right? Minimum speed is 1. And that is kind of my left pointer. The next thing that I need to find out is the maximum speed possible, right? And the maximum speed will be the largest element in my pile. So I run a for loop to iterate over each of these elements and find out that, okay, 11 will be my maximum speed. So now I have two pointers, one at the number 1 and one at the number 11, correct? The next part is just a binary search. I am running a while loop until my left pointer is behind my right pointer. And I will find out the mid value. Upon finding the mid value, I get the mid value as 6, correct? And now I need to determine, hey, with the speed of 6, can I eat all the bananas? So that is why I have a helper function over here. This helper function is just telling me, hey, will I be able to eat all of these bananas with this given particular speed? So what I do over here is I initialize my hours taken to 0 and then I iterate over each of the pile and I take the ceiling value. So let us say I have 3 bananas in my pile and I am only eating 2 bananas per hour. So that will give me a ceiling value and I will get 2 hours. So I add up all of these hours and then return, hey, can I eat in this particular speed? In this particular condition, with a speed of 6, I will be able to eat all the bananas, right? So what I do is I set my max speed to mid. So what will happen is this right pointer, this will start pointing at the mid value, right? Once again, this loop will run and you will find out the mid value between 1 and 6. The mid value you will get is 3. Once again, you will find out, hey, can you eat all of these bananas with a speed of 3? With a speed of 3, if you remember, the total time taken was 10. So what will happen is, in this loop, the min speed will be set to mid plus 1. So this will move my left pointer ahead. This loop will now go on and ultimately your low and high pointers will arrive at the same point. As soon as that happens, you return the minimum speed, which will be pointing at the minimum speed needed so that Koko can eat all of the bananas. I hope I was able to simplify the problem and its solution for you. While going throughout the problem, you must have noticed that as soon as you find out, okay, I can apply the binary search algorithm, then most likely it is the most optimal solution. Because a binary search technique works in an order of log n time complexity. And it is very, very fast because at every iteration, you are discarding half of your sample size. So the time is actually exponential and you solve the problem very, very fast. So while going through the video, did you face any problems? Or do you have any other approach in mind by which you can approach this problem and in an even faster way? Tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, a huge shout out to all the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments as well. Stay tuned for my next video. Until then, see ya.